Hello friends, once again very welcome to all of you. Now we have to discuss about the address mapping chapter of TYBCS subject computer networking part second. In this chapter we have to discuss about the protocols to create a mapping between physical and logical addresses. For that purpose, this chapter contains address resolution protocol, cache memory, ARP packet format, encapsulation, different cases related to the address mapping, then mapping physical to logical address, ARP protocol. We have to see these all of concepts but with the help of PPT. So let us move towards the PPT of this chapter, that is address mapping. So we know that this chapter has few objective. Here we will going to study about host to host protocol using the logical addressing to make IP more useful. We need the help of other protocols. So here question may be arise, what is address mapping? In internet there is a combination of physical networks connected by routers to reach up to the destination. Packet may pass through several different physical networks. The host and routers are recognized at the network layer by their logical addresses, that is IP addresses. Packets pass through physical networks to reach up to host and routers at the physical layer. The host and routers are recognized by their physical addresses. A physical address is local address which is unique for that network. It is usually implemented on hardware. The example of physical address is the 48-bit MAC address, which is imprinted on the NIC installed in the host or router. The delivery of packet to a host or a router requires two levels of addressing, that is logical and physical. We need to be able to map a logical address to corresponding physical address and vice versa. This can be done using either static or dynamic mapping called as address mapping. So to do that there is address resolution protocol, that is ARP. When host or router wants to send a packet to another host or a router, it has IP address of receiver. It can be obtained by DNS, but IP datagram must be encapsulated in a frame to pass through the physical network. Sender needs the physical address of receiver. Sender sends ARP carry packet. The packet includes the physical and IP address of sender and the IP address of receiver. Here we have to assume that sender does not know the physical address of receiver. This is broadcasted over the network. Every host on the network receives request and process it, but only the intended recipient recognizes its IP address and sends back ARP response packet. This is unicast direct to the sender since recipient knows about sender's logical and physical addresses. So see it in the figure given here. System A wants to communicate with system B with IP address, but system A don't know physical address of system B, so it uses ARP broadcast service of the protocol as shown in given figure, and it broadcasts the ARP request to ask about physical address. This request is received by every system on that computer network, but only the system B gives a reply as shown in figure. System B sends ARP reply packet which contains its physical address and unicast it to the system A. So now next point is that cache memory. ARP can be useful if the ARP reply kept in cache memory for a file. Here, suppose if a computer X wants to send several packets to the Y, computer X don't know the physical address of computer Y, then several times computer X has to broadcast the ARP request to the computer Y, which is inefficient. ARP can be useful for the if ARP reply is kept in cache memory for a while, because a system normally sends several packets to the same destination. A system that receives ARP reply stores the mapping in the cache memory. The reply is stored for the 20 to 30 minutes unless the space in the cache memory is exhausted before sending the ARP request. The system first checks its cache to see if binding is stored or not. So to see now ARP packet format as shown in figure. Here in this figure, ARP packet format contains different types of fields. First field is that there is hardware type. It is of 16-bit field that defines the type of network on which ARP running. Each lane has been assigned an integer based on its types. Its example is Ethernet 1. Next field is that protocol type. It is also 16-bit field that defines the protocol. ARP can be used with any higher level protocol. Next field is that hardware length. It is of 8-bit field that defines the length of physical address in bytes. For example, Ethernet, but value is 6. Next field is that protocol length. This is 8-bit field that defines the length of logical address but in a bytes. For example, IPv4 has a value 4. Next field is that operation. This is also 16-bit field, has the type of packet. That two type of packets are ARP request 1 and ARP reply 2. Next one is that sender hardware address. This is variable length field, defines the physical address of sender. Its example is for Ethernet, it is of 6 bytes long. Next field is that sender protocol address. This is also variable length field that defines the logical, that is IP address of sender. For IP, this field has 4 bytes long. Next field is that target hardware address. This is also variable length field that defines physical address of the target. For ARP request, this field is all zeros because the sender does not know the physical address of the target. Here target is destination. Another field, target protocol address, that is destination address protocol. This is also variable length field that defines the logical, that is the IP address of target. For IPv4, this field has 4 bytes long. Next field is that there is a encapsulation. When an ARP packet is encapsulated into data link frame, it shows an ARP packet is encapsulated in Ethernet frame. Type field indicates that data carried by the frame are in an ARP packet. So these are the different ARP packet fields which are used in ARP packet format. We have seen encapsulation also here. So next point is that operation. Let us talk about ARP functions on the internet. First we have to discuss, there are few steps that are involved in it. Then we will going to discuss 4 different cases in which host or router is to be need to use ARP. For that there are steps. That steps are the sender knows the IP address of target. Next one is that IP ask ARP to create ARP request message. In request message, sender physical address, sender IP address and target IP address are to be filled. The target physical address field is filled with zeros. The message is passed to the data link layer. Data link layer encapsulate in the frame by using physical address of sender as the source address and physical broadcast address as the destination address. Every host or router receives the frame. All machine discards it except the targeted computer. The target machine replies with an ARP message that contains its physical address, but this message is unicast. Next one is the sender receives the reply and knows the physical address of targeted machine. The IP datagram which carries the data for target machine is now encapsulated in a frame and is unicast to the destination. So by considering these steps, there are 4 different cases as shown in figure. Case 1, a host has packet to send another host on the same network. In this case, logical address must be mapped to the physical address of destination as mentioned in IP datagram. Second case is that a host wants to send a packet to another host on another network. It must first be delivered to a router. In this situation, host looks at its routing table and finds the IP address of the next hop, that is router, for this destination. If does not have a routing table, it looks for the IP address of default router. The IP address of the router becomes the logical address that must be mapped to the physical address. The third case is that a router receives a packet to be sent to host on another network. It must first be delivered to the appropriate router. It checks its routing table and finds the IP address of next router. IP address of next address becomes the logical address that must be mapped to the physical address. Fourth and last case is that a router receives a packet to be sent to a host on the same network. The destination IP address of the datagram becomes the logical address that must be mapped to the physical address. To understand it, a host with IP address 130.23.43.20 and physical address B23455102210 has a packet to send another host with the IP address 130.23.43.25 and physical address A460.45983 The two hosts are on the same Ethernet network, so the ARP request and reply packets encapsulated in Ethernet frames as shown in this figure. So our next point is that Proxy ARP. Proxy ARP is the technique in which one host, usually router, answers ARP requests intended for another machine. Proxy ARP used to create subnetting effect. A proxy ARP is an ARP that acts on behalf of the set of hosts. Whenever a router running a proxy ARP receives a request of IP address of one of these hosts, the router sends an ARP reply of its physical address. After the router receives the actual IP packet, it sends the packets to the appropriate host or router. The advantages of this proxy route ARP is that it must be used in network layer. It will be added to the single router. Though it has advantages, it has also disadvantages. First disadvantage is that it increases the traffic. Host needs larger ARP table and security can be undetermined is the disadvantages of proxy ARP. So in the figure here shows that whenever request for 1412356 21, 141235622 and 141235612. These hosts coming from the subnet A. Proxy router immediately sends its own physical address as a reply. When the proxy router receives the IP packet, it sends the packet to the appropriate host. Proxy router is able to do so because it knows both addresses of the connected host as shown in given figure. So our next point is that there is mapping physical to logical. In it, first point is that RARP, that is RARP stands for reverse address protocol, which is used to find logical address of a computer which knows only its physical address. Every computer and router is assigned an IP address which are unique on the network and independent of physical address. To create IP datagram, that is packet, computer or router needs to know its IP address. IP address of a machine is usually read from its configuration file stored on a disk file, but whenever a diskless workstation is booted, it uses ROM, which is installed by manufacturer. So next point is that Bootstrap, BOOTP, that is Bootstrap protocol. It is client server protocol. It is used to provide physical address to the logical address mapping. It was originally defined in RFC 151 standard. It is of application layer protocol. Our next and last point of this chapter is DHCP, that is Dynamic Host Configuration Protocol. It is dynamic mapping protocol. It provides binding between the physical and logical, that is IP address of the client which is already exists. This binding is predetermined. It provides static as well as dynamic address allocation. Static allocation is work same as Bootstrap, while dynamic allocation is work with the pool of IP addresses. So friends, here we have seen the chapter address mapping. We have seen the mapping of physical to logical, then the different cases of this chapter, then different protocols which are work here. So I hope that you have understand the concept of address mapping. Thank you.